Okay. So yeah, thank you everybody for joining. Leonardo is our colleague from OCHA, Predictive Analytic Unit, and together with his colleague Tinka, they agreed to present to us in more details what is predictive analytics and its implications to the humanitarian work. So Leonardo, over to you.
Thank you. Good morning, good afternoon, everyone. So first of all, it's a big pleasure for us to present some of the work that we have been doing around predictive analytics and some of the projects that we have been working on in the last couple of years. I will be, so we have some slides, but the idea for today is really to keep this as an open discussion. So feel free to interrupt at any time if you have questions or if you have comments or clarifications, or if you just have, ideas that come to your mind. Let me start. I'm Leonardo. I joined OCHA in 2019, and I'm leading the predictive analytics team. Before joining OCHA, I was with the Norwegian Refugee Council, working on modeling of internal displacement and migration, but my background is in science. I'm a physicist by training. So together with me today, I have Tinka Valentin. So maybe Tinka, can you just introduce yourself, and then we can start with the presentation.
Yes, hi everyone. So I'm on the team with Leonardo. I'm a data scientist there, working a lot with anticipatory action, and my background is in machine learning. So I've done different projects, for example, related to damage assessment from satellite imagery and this kind of thing. So yeah, really excited to discuss here what we can do and what we cannot do with predictive analytics.
Okay, so what we would like to discuss with you today is really, so first of all, like kind of an introduction to predictive analytics, but then we would like to give you some concrete examples of how OCHA and other partners are using predictive analytics. I know that there is a specific interest from this group in exploring one specific approach within the field of predictive analytics, that is machine learning, to food security and nutrition issues. So we can give you an example from one model that we have reviewed lately. And then I would like really to take some time just to clarify what are the opportunities, but also the challenges when related to predictive analytics. So really looking at what predictive analytics can and cannot do, because if this is clear from the start, I think we may avoid issues in the future. And then of course questions and answers, but really please interrupt us at any time. Okay, so we have a glossary on the website of the Center for Humanitarian Data, and we have we tried to give a definition of predictive analytics, and this is, I mean, there are several definitions, but this is one of the this is the best we could actually come up with. So we are linking predictive analytics to the analysis of current and historical data to anticipate an event or some characteristics of an event. So, and I think there are three key elements. So first of all is the fact that predictive analytics is an analysis, and the fact that we are analyzing data means that we have assumptions that we are introducing when we take decisions in our data analysis. The second one is that is based on observations, so current observations and historical data, and this is really like what most of the models we are working with are using to learn and to be able to say something about what is likely to happen. And then the third element is really that a model is designed and developed with a specific goal. So the goal can be to anticipate an event, so knowing when the next flooding is likely to occur in a given region, or some features, some characteristics of an event. What's the severity of a food security crisis? What's the magnitude of the impact of a typhoon or a cyclone, or what's the duration of an epidemic? I mean, we are all familiar with COVID models and how they have been used. So the first point I want to make also is that predictive analytics is something that is really around us. And in our daily life, we have models influencing our decisions every day. So when we when we work on Google, when we check the weather forecast, when we look at the information on traffic, when we get feeds from social media, marketing, and so on. I'm actually in full screen, so I cannot see the comments in the chat. So I don't know if Tinka, you can check, and if there's anything, just stop me, and then we can answer questions. If there's anything that we need to address on the way. The point is that in the humanitarian sector, the application, predictive analytics is not a new field in itself, but the application of some of these tools specifically to the humanitarian sector is quite new. And as you know, many organizations are investing more and more in increasing their capacity to understand models, to use models, to develop models, and to increase their analytical capacity. Sorry, I'm jumping through the slides. This is not really working. Okay, so let's talk about predictive models. So at the core of predictive analytics, we have a model. So when we think about a model, most likely we think at structural models. So really a model of a building, or a model of a house, or really like more in a structural way. And if you think about it, like even when it comes to predictive analytics, if we see models as a representation of the reality, that's what it is. And instead of having structural models, we have mathematical models. So the point I want to make here is really that we are trying with predictive analytics to understand some of the dynamics, some of the how the reality, our system works, to then make assumptions and try to project how it's likely to behave in the future. And the other point I want to make around predictive analytics is that models are something that our brain is constantly using. Let me give just a fun example. So I'm taking this picture really to give an idea of how our brain works, how our brain analyzes the information to take the best decision. So in this example, clearly the man at the back at the end of the line needs a model, needs a good prediction of what is the fastest line at the supermarket. So clearly already like the goal of his mental model is clearly defined. So the model needs to predict what is the shortest line. Now, based on this, we know exactly what is the target variable. So that is the time spent in the line that we want to minimize. And this is already like giving an idea of what is, if you translate this then into, the type of models that we're using, what is the, the target variable or the target intervention that we want, or process that we want to optimize. Now, based on his past experience, he knows what are the factors, what we can also call features, that may impact the target variable, the time that you have to spend in the line, which can be the number of people in waiting in line, the number of items in the baskets. So implicitly, what our brain does is really taking all these inputs, analyze the information, and taking the best decision based on what we know from the past. So our brain, without really knowing, I mean, this is done pretty much in an automatic way, analyzes this information and estimates what is the best line. And that's the line we get in, which is a simplification of how a model works, but it kind of gives you an idea that it's really something that is not too far from our way of thinking and our way of taking decisions. Mm-hmm. So let's look at this in a more detailed way. So based on the definition, also this example, you can already understand that there are different elements, different inputs to a model. First of all, is based on data, and usually, many models are really data hungry. And then there are assumptions. So, and going back to what I was saying before, predictive models, well, models are a representation of the reality. So they can, and they are usually a simplification of the reality. So we need to make assumptions when we build these models. I don't know if someone is as a comment, or someone is unmuted. And then there is the model itself, really the machine learning component, the algorithm, and the statistics. And and we'll give some details also on this in the next slides. So how a model works is really by looking at what we want to model, what we want to predict, and this is really what's the outcome that we want to project in the future, and what is having an impact on this. The example before is really what we want to model is the time spent in the line, and the features are the number of people waiting, the number of items in the basket, and so on. So what usually a model in many cases works exactly in this way. So a model learns from the past, tries to predict the past, so what we call hindcasting, basically knowing what happened in the future, trying to predict what happened in the future, and in this way the model can improve. And so also another key element of this of the development of predictive analytics is that models get better and better as more data is available and is analyzed. One comment that I would like also to make is really, so the starting point is really is having a good understanding of the problem, having a use case very well defined. This is really one of the key elements for success. Then this informs the technical development, the evaluation of the model that may lead to a better understanding, and there's a cycle that is generating. But at the end of the day, what really makes a model successful is the action that is generated by the model. And especially in the humanitarian sector, you may be already aware of, many models that are available to, for decision makers, but not many of them are actually able to generate a concrete impact, are models that can really influence decision making in the humanitarian sector. And this is very much what we are trying to do at the Center for Humanitarian Data and with my team, really supporting decision makers using models and using predictive analytics in an impactful way, understanding where, how, and when models should be applied, what are the strengths and the weaknesses, what are the ethical risks involved in the use of predictive analytics for specifically in the humanitarian sector. So to kind of start with, it's really, I tried to collect some of what I think are the key questions that should be very clear for a group like this, that is willing and that is, wants to start exploring the use of predictive analytics. So it's really about really the use case, about how a model will be used, what is, what's the gap that the model should be filling. If we know already enough about the dynamics of the system that we want to model, if we have already a clear benchmark of what a good enough model would look like. So what is the models are not perfect. So if you have already an idea of what is an acceptable level of performance. And then looking, of course, at data availability, because in many cases, this is one of the main limitations. And before actually leaving the floor to Tinka, that will say a bit more specifically around machine learning and other specific applications, I just want to remind you that predictive analytics is always as good as the data that we have. So, and using models is not a way to replace improving data collection, improving data quality, and so on, and the assumptions that we make. So that's really like our understanding of the problem. So let me maybe pause for a moment here if you have comments, questions, anything. If not, we can move on with the next part from Tinka.
Hi, Leonardo. I have one question, maybe a clarification one, about the statistics and the machine learning. I know you put them both together in one of your slides. So data, assumptions, statistics, and machine learning, right? So I've always thought that, okay, if you have the data and the assumptions, you can already use statistics available statistics to predict your outcome. But machine learning and other things come kind of an extra, no? So if you have a lot of data, a lot of statistics already, then you apply machine learning to improve your predictions, right? Is that correct, or?
That's absolutely right. So what at the end of the day, also, like, machine learnings are statistical models. So that's why I put them together. So it is really like an improved way of using, basically statistical models. So that's why they are together. But yes, I mean, the same goes with without going to machine learning models, if we do statistical analysis, but the same applies to the analysis that we are all already using. Yeah, but that's a good point.
Okay, thanks.
Maybe over to you, Tinka, and then we can pause for another moment for other questions.
Yes, perfect. Thanks, Leonardo. So yeah, I will shortly dive into what exactly machine learning is, because we often hear this word, but what is it? So it's actually a subset of predictive analytics. Can you go to the next slide? So what we just talked about, predictive analytics, and the great question from Douglas, it means any kind of model that can sort of predict an output based on data we give into it. But there's not much of a definition about what kind of model it should be. And then if we go towards artificial intelligence, another term often used, it specifies a little bit more what the model should do. And the most commonly used definition of artificial intelligence is that it should mimic human behavior, basically. And this is very vague, but it's trying to do things that normally humans would do. So for example, playing chess, any computer can do it better than any human. So this is based on artificial intelligence. And then a subset of artificial intelligence is machine learning, what we were just talking about. And the definition of machine learning is that it learns from the past. So it means that you have a model that can, to a certain extent, learn things by itself based on the data we give to the model. And then every time it gets new data, it sort of improves its predictions. And this has become really popular in recent years because we got better data and better computers, basically. And then another term you might hear often is deep learning. And this is again a subset of machine learning. And what makes deep learning different from machine learning is that with deep learning, you use a specific type of model, which is called neural networks. But what it's very good at is that it's very good at handling a huge amount of data. So for example, when we work with images, often deep learning is applied. Can you go to the next slide? So going back to machine learning, I just said that it means it learns from experience. So what kind of ingredients do we need for a machine learning problem? We need three things. We need data, a model, and a definition of what we want to predict. And what we're basically doing is that the model tries to find a sort of mapping from the data we give it as an input to the thing we want to predict. So for example, the example Leonardo gave earlier, we want to predict what the time will be in each lane in the supermarket. And then we give some data variables that might be related to it. So for example, the number of people in a line. And then the model maps this number of people to the time. And it does it by just trying out different mappings. And then during a period we call training, it also gets the real values. So it actually knows what the amount of time was that people spent in a line. And then based on that, it improves the workings of the model. It improves the mapping from this input data to the outcome. And that's basically it. And then you can change what kind of model you're using. Yes, next slide. So we want to predict something. So for example, the time spent in a line. And this is one kind of prediction model, prediction problem, but there's different kinds. And generally we can divide them into two classes, namely classification and regression. And classification means that the output is discrete. So there's a limited number of possibilities. And an example of a question we could try to answer is related to food insecurity. So it's more than 20% of the population of a certain area in IPC 3+. And so this can either have the outcome yes or no. So it's only two options. And then if it would be a regression problem, it can be continuous. So it can take any number. So for example, what percentage of the population is in IPC 3+? So then it can be any number between 0 and 100. And so for these different kinds of outputs, we need different kinds of models. And I'm not going to go into any details of any model, but I just wanted to mention two names because you might hear them often or read about them, which are random forest and linear regression. So these are two types of models that are really often used for classification and regression, respectively. Yeah, next slide. And so that's in a nutshell how machine learning works. And to make it a bit more concrete, I took one example, a model used in the humanitarian sector, namely Artemis. So this is developed by the World Bank, among others, related to food insecurity. So what they do, so we need the three elements. We need what we want to predict, we need the data, and we need a model. So how they decided upon this is that for prediction, one of the parts of Artemis uses classification. So the question they ask is, will the IPC phase of an admin2 region change from IPC 1 or 2 to IPC 3+? So they define this as like an outbreak of a food insecure situation. So that's what they're trying to predict. So there's two possibilities, yes or no. And then they look at a lot of different data sources that might have some correlation with this transition to IPC 3+. And all the different data sources they use, we can divide them into 4 different categories, namely structural factors. So for example, related to demographics or land coverage. Environmental factors, so for example, hazards, violent conflict, and food price inflation. And then they give this to the model, and the model they use is a random forest model. And so basically the model learns to map all these different factors into a yes or no answer if there will be an IPC 3+. Next slide. And well, it's important to notice that this is a model, so it will never be 100%. So it seems to work pretty well according to their papers. And in the documentation they also give 3 considerations that are really important to take into account, I think, when developing these kind of models. So it would also be important for your work. And the first one that we already touched upon is data availability and quality. So your model or your output only gets as good as your data. It's sometimes pretty hard to get good quality data, and it also might differ per country. So it's important to consider how you deal with less good quality and if that has a really big impact on your outcome. Then the other thing is lead time. So how far ahead do you want to predict? So for example, the Artemis model predicts 4 to 12 months ahead. And of course, the further you predict ahead, the less certain, the less accurate often your predictions become, but you have information earlier. So it's really a balance between what is the most important thing you have to know. And then the last thing is sensitivity. So the model is never going to be 100% correct, but you can make decisions on what it will be better at predicting. So this is about over or under predicting mainly. So for example, with the Artemis, so if there will be a change to IPC 3+, you can tune the model to either too often predict that there will be an IPC 3+ transition or too little. And this is a choice you have to make as designers, to see what is more important. So yeah, that's all I wanted to tell for now. I think we can have a little other break for any questions that come up, and then there's a last third part of the slides we have.
Yeah, and Tinka, maybe you can, we'll share the slides, but maybe you can put the link to the Artemis publication or to the Artemis model in the chat, one of the papers that you mentioned. So do you have questions or comments at this stage, or should we move on? I guess.
Hi, just one question. You talked about 2 methods, right? Basically, regression and random forest. I've seen the support vector machines as a method used in at least in one country. Does it come under one of these two, or is it a separate method, or could you elaborate on that?
Yes, of course. Yeah, so they definitely come under the, actually you can use them both for classification and regression, but often they're used for classification as well. So yeah, this is definitely, support vector machines is definitely another kind of model that's very often used.
So it's regression or support vector machine under the prediction, or they are all, how would you classify?
So it's most often used for classification. Yes.
Okay.
May I ask a clarifying question?
Of course.
Sorry, Anna. Just the question, there was the specification of lead time. Is the lead time the duration period over which the data was collected, or is that the amount of time that has lapsed since the data was collected? Over.
It's sort of, it's the, how is it? The time you want to predict ahead. So it's probably the time between the data was collected, and so from the point the data was collected to how far you want to predict ahead. So for example, if we collect data now, so it's January, then if there would be a lead time of 4 months, it would be in April. That we, yeah, the numbers we predict about. Does that answer what you meant?
That's perfect. Yeah, thank you so much.
Yeah, I was going to say there is a question from Shabi.
Yes, just regarding the, thanks Anna. Regarding regression and classification, while you are talking, I just want to mention to our team in future, maybe for classification, if we can come up with ideas, for example, from picturing the children, we can know he is malnutrition or non-malnutrition. Regarding regression, yes, we face in countries, we cannot predicate the GAM or SAM survey unless we do the smart survey. So if we can have a model with the experience of people here to regression and predicate the GAM rate. And just the question for you, both of you, what are the recommended platform you advise to build the model? Azure machine learning or Python or R? Thank you.
Great, thanks. So for the platform, I think there's a lot of different possibilities. We do most of our work in Python and sometimes in R, but you even have platforms that take over most of the programming for you. So it really depends what kind of expertise you have within the team, what is the best fit, and also what kind of models you're using, because if you get into really complicated models, some platforms can handle that better. Yeah. And I just wanted, yeah, go ahead.
Sorry, go ahead.
About the classification and regression, I just wanted to mention that it's often a bit easier to get a good classification model than a good regression model, because for regression, there's way more possibilities. So yeah, sometimes it's better to actually start with a classification. If that provides the information you need, I would recommend that. But
yeah, usually is a simpler problem. It's basically yes, no, rather than how much type of model. Just the point that you made is actually very important. So one thing is really using models to project in the future. The other thing is using models to do what is called nowcasting. So basically, if you cannot collect directly data and do your data collection exercises, maybe you can use proxy indicators to estimate GAM and SAM rates, for instance. This is definitely another application of predictive analytics, and this I don't know if you're familiar with the work done by WFP, the hunger map. That's not very different to what they have on that platform. So based on a number of other indicators, I think in that case they have their food consumption score, or a different metric. Is not GAM or some rates, but yes, that's definitely something that is within this the scope of the application of this type of models. Elisa, I see you have your hand up.
Yes, thank you. I wanted just to add on our experience using models in emission estimates, or for example, in the tool that WHO has developed with UNICEF and other partners, that is the Global Nutrition Targets Tracking Tool. So what we do is that we collect as data the surveys that have been done at country level, so national surveys. So the issue is for some countries, for example, in Africa, especially in West Africa, we have surveys every year. In other countries, we have just perhaps every 5 years, we have the DHS mix, perhaps some national nutrition surveys. In other countries, we don't have data at all. And then we use a model that I'm not a statistician. I have a colleague that developed this model. And I think it's a regression model. And with this, we try to have regional and sub-regional and global estimates for wasting, stunting, and overweight. And this is used most with one aim of advocacy to inform, for example, donors, to orient donors and inform countries on progress, on how they are progressing to track and reach the global nutrition targets. Someone was asking about the predictions. So a similar model has been used, or I don't know if really very similar, for the tracking tool. I don't know if you are familiar with this tool. So using the point estimates of the countries that have several surveys. So we have, these statistic colleagues have estimated what they call AARR, that is average annual rate of reduction, for example, for stunting, and for the 6 global targets. So you can put, depending of, I understand the AARR as the velocity. So depends, so you can play, you have and what if, so depending of the velocity you want to put in the country, for example, depending of resources available. So you can estimate how far, how many times you will need to reduce stunting to reach the country nutrition target, for example. This is, for example, for wasting, this is not possible because we know that wasting is very influenced for the context and for shocks, but this is very valid, for example, for stunting and for overweight. We have as well for the exclusive breastfeeding. So I wanted to share this experience with you because it's the kind of indicators that most of us, we are used to. Thank you.
Thanks. So let me move on very quickly. I don't want to spend too much time on this presentation, but leave some time for further discussion. But I just want to kind of manage expectations around predictive analytics. So first of all, some of the things that you need to keep in mind is that a prediction always has an uncertainty, and that's something that we have been learning, and something that is many times hard to communicate with to decision makers. But there's always, I mean, we're estimating a probability of something happening. There's never a prediction that is 100% certain, and this needs to be reflected in the way we use predictive analytics. For instance, some actions may be taken on a no regret basis, so without really questioning whether the forecast is then realized or not. Predictive analytics, and especially machine learning, kind of understand and are good at estimating the, if you want, the hidden patterns between what's causing the variable of interest, what's impacting the target variable, and the different features, but they're not usually very good at explaining why. So to some degree, and you hear many times that they are kind of black boxes, and this is to some degree for some models true, but they find the best solution to a problem, but not necessarily explain why that's the right solution. This may also have an impact in the way you present the findings and you implement these models. This is exactly what I was mentioning before. Is predictive analytics is not only about predicting the future, filling that data gaps, and what I was saying with using proxies to estimate, for instance, the indicators in the smart surveys, or finding anomalies. So looking if anything is really like suspicious in the data. That's what is called anomaly detection, or just doing more like risk analysis, or what is the underlying risk. So without looking at a specific discrete event, but more like if you want a probabilistic risk analysis. Machine learning and many models learn from the past. That means that they apply what they have learned in the past to the future. So they are actually doing a pretty good work in predicting the future if the future is behaving kind of like the past, or to some degree like the past. For very sudden events or out of the ordinary events, or like where the dynamics is completely different, they usually fail. So COVID-19 was not in any epidemic model in 2019, and the same for the Syrian crisis and so on. But for context where we have a clear sense of what's the dynamic that is driving humanitarian needs, that's a good application. Models can be biased, and they can have many different biases, and that's something that we should all be aware of, because the data that we're using to train the models can be biased. The assumptions that we make, the way the models are interpreted. Let's imagine that we use a model that is using data, but because of access constraints, the data is not representative of the population of the country. That's a clear bias that we're introducing. So these are all things that needs to be evaluated and taken into account. And we have already seen in many other sectors that they can, that this like relying blindly on models can have a negative impact in the job market. There are more and more models deciding if you're getting an interview or not, but even in the judicial system. This is like an important topic to consider as well from more like the programmatic and operational point of view. And that's why I want to stress that really in the application, in a successful application of predictive analytics, the biggest challenge is not the technical development, is really like how we design and we deploy models. So asking the right question, getting the data that is reliable, building confidence among stakeholders in the model, and clearly define the rules of the game. That's definitely as important as the technical development. Just wanted to mention very briefly a couple of things. Predictive analytics is new in the humanitarian sector, and what we have developed is a framework to evaluate models, and it's really a framework to support decision makers. and really to really evaluate different models, not only from a technical point of view, but also from an operational and an ethical point of view. That's what we call a peer review framework for predictive analytics in humanitarian response. And this is really like, how do we best, so the key question is really, how do we best support decision makers taking the right action based on a model that is, you know, understood, and we don't implement programs when we know that models are not accurate or are biased. Looking exactly at the, you know, also some of the ethical issues that's something that we're doing with our team working on data responsibility. We're also maintaining, and that's something you can find on the center's website, a catalog of predictive models. Really, who's doing what, when, is like the 4 Ws for predictive analytics, so that if you're interested in knowing, for instance, what are all models related to conflict and violence, migration in a given context, you have key contacts, some meta-analysis that we have done, and, you know, kind of easier to compare. And just to conclude, is one of the main applications in OCHA is related to anticipatory humanitarian action. So how can we use predictive analytics to anticipate those shocks that can be predicted? And this is, you know, something that is very high on the agenda of the Undersecretary General at OCHA. So just to give an example, and this is something that we're doing with CERF, the Central Emergency Response Fund. So whenever there is a crisis right now, the system does, you know, collects data. So humanitarian needs are assessed. At that point, we enter the planning phase, we define the priorities, and then, you know, money is allocated based on the planning. The idea of anticipatory actions is really to replace the shock with a forecasting, so a model, instead of, you know, deciding what is the action plan after shock. Already have a pre-established action plans that, you know, are meant to mitigate the impact of an upcoming shock, and to have a pre-agreed arrangement with, in this case, would be with CERF. That's basically what IFRC also calls forecast-based financing. FAO and WFP are also active in this space, but with CERF is really like, you know, all the clusters, and, you know, it's the entire system that is set in motion in anticipation. If we act early on, the overall number of people in need will be reduced, the cost of response will be lower, and also, you know, like we would preserve some of the development gains that are, I mean, in this context. We have been doing this for food security in the Horn of Africa. We had the first application, first, you know, activation of this framework in Somalia in 2019. We are likely to release additional funding because of the upcoming forecast for the March, April, May season in Ethiopia. We are doing this for sudden onset disasters. Flooding in Bangladesh is an example. We're expanding the Bangladesh experience to other countries, exploring if we can do something similar for cyclones and typhoons, and other infectious diseases such as cholera, for instance. It seems like a potential use case. Yeah, this is what I said. So why, especially in our context, we are very much interested in you know, exploring the opportunity that predictive analytics represents. And I think yeah, that's it. So just one slide on the center. So it has really been established to increase the use and the impact of data, and now also more like analysis in humanitarian response. We're working on, you know, different topics. So we are managing HDX. You're probably familiar with that. We have a data responsibility team that works on data sharing and supports really around issues around the management and the use of data. A data literacy program to support the system, using data and analysis in a better way, and then our team working on predictive analytics. And I think, yeah, that's it from our side. That's what we wanted to tell you today. I hope it was helpful, and I'm looking forward to discussing with you. Thank you.
Thank you, Leonardo. Does anybody have any final questions on the presentation?
Yeah, Leonardo, thank you for very much, and Tina also for this. Just one question about the application. You mentioned a few countries where you have done this analysis, and also you said you talked about cholera. You mentioned cholera. So could you let us know a little bit more about what outcomes did you consider in any of these countries? Because OCHA is kind of overarching body, right? So you work with, there are many different sectors involved. So I was wondering if you can tell us about what outcomes did you predict, and how it worked, and using a example. Over.
Yeah. So unfortunately, I cannot say much around cholera because we are at the very, very beginning. So we are in touch with UNICEF. We are in touch with the WHO, the Global Task Force on Cholera Control. There are a number of universities actually looking at how they can, environmental factors can be used to project the risk of cholera outbreaks. So we are very much, exploring opportunities in this space. For Bangladesh, it was so the outcome that we were looking at, it was number of people that will be inundated, that will be affected by seasonal floodings. And we have established, so we designed the trigger, this on the model that at the end of the day is a threshold on the risk of flooding to be the return period to be 1 in 5 years. And the lead time for Bangladesh was 5 days. So we only had 5 days to implement the intervention. So that was mainly cash plus a number of other small interventions that could be implemented within the short time. The lead time is much greater in Somalia and Ethiopia, for instance, where we have really, depending on the seasonal calendar, different interventions that need to start at different moments in time. And there, the hope is really to be able to release funding months before the rainy season, months before the harvest. And the main outcome we're looking at right now is based on IPC phases. So basically looking mainly at the projected IPC scores, using a variety of models, not only the projections from FuseNet IPC, but also at the expected impact, looking at crop production. And, we are using more, and we are trying to use more and more, different indicators in addition to the analysis done by these two organizations. I don't know if that answers your question.
Yeah, that's very, very good. Thank you. But also, I was just wondering, like whether you look at the shocks itself or the impact of shocks on intermediate indicators, and then the impact of intermediate indicators on outcome, no? Because like COVID is a big shock, but COVID has implications, several implications on several sectors. And then if we apply that to nutrition, then, you know, so for us, it would be like, okay, COVID has impacted on markets, food security, health, etc., and how they are going to impact on nutrition, for example. No, so otherwise, so the shocks will be different, right, from context to context. But if we look at the intermediate impact and then the overall outcome of interest, then that would make more sense, no? Or how would you do that?
Yeah, absolutely. Absolutely.
Yeah, okay.
So that's, yeah. So usually, I mean, if you look at also the work done by other organizations, these models and these programs are based on expected impact. Just to, and it can be even more specific that, for instance, in Somalia is food security related to drought, or where drought is a major, is one of the components or one of the elements of the stress factors. Just because then if you need to decide before the types of interventions, if it's, you know, food security because of political violence, some of the interventions like distributing drought-resistant seeds are not, you know, relevant. So in this case, specifically for food security in Somalia and Ethiopia, well, there was one component looking at the seasonal rainfall forecast. So really show, you know, to understand whether the expected rainfall and the expected crop production is going to be below average, and then impact on food security of this. Of course, you cannot just think about, you know, food security as being just, you know, due to drought, but where at least drought is one of the stress factors. But yes, I mean, IFRC is always what they call forecast-based financing, is always based on impact, because you don't want to, even a shock happening, you know, without serious consequences, that's probably not what you want to respond to.
Thank you, Leonardo. Some people, including me, who will have to go now for another call. So thank you for this presentation. I think as a way forward, maybe we can, as a NIS working group, discuss implication for us at the next meeting. And then maybe if somebody still have questions, may just write them to me, and I will send them to Leonardo and Tinka for their reply in case you did wanted to ask something and there was no time. So thank you. Thank you.
Thanks.
Thank you, Leonardo.
And
thank you,
talk to
Tinka.
you
Thank you, everybody.
very soon.
Thank
Yes,
you.
absolutely.
Yes, thank you.
Bye-bye.